Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. In the previous video tutorial, we used our LandSat images derived from the LandSat 5, 7, 8, and 9 data sets, and we generated the Normalized Difference Vegetation Index using some mathematical expressions in the code editor. So we generated the NDBI by using the NDBI formula, which basically includes the near infrared and the red bands, either subtracting them and then adding them. In that combination, we then are able to calculate the NDBI. We set that the NDBI ranges between -1 and 1, where -1 is either no vegetation or very bad vegetation or low health vegetation, where 1 is lots of vegetation, good quality and good health vegetation. And we used our visualization parameters to create a visualization palette, a color palette, where we are able to visually present the NDBI image for each of the LandSat data sets, etc., etc. So let's continue from where we left off. Remember, we're busy generating indices from our LandSat data sets. So we go to our Earth Engine. From the Earth Engine, we go to our script. Here is our script. And remember, we then calculated, let's go there. We created first a visualization parameter for each of the indices. In our case, we used this color scheme for the NDBI visualization. Remember, it's -1 and 1. We then created this, used this visualization scheme or color scheme for the Normalized Difference Buit-up Index, and we used this color scheme for the Buit-up Index. Okay, so remember, we generated these color schemes by using the color parameters for each of our LandSat layers or LandSat images, and we just simply, as I said, used our option there to create the color scheme, the palette, and from there we simply just import it and then we copied and paste the color codes into our script. Okay, so we've initially created the colors codes and the visualization parameters. We did that, and then we actually created the script where we generated the NDBI for the LandSat LandSat 5, 7, 8, and 9. And again, please remember to make sure that the LandSat 8 and 9 bands are adjusted from LandSat 5 and 7. Okay, so just make sure that you understand that, or take importance of that. Okay, then as I said, there's the expression. In our case, remember the NDBI is the infrared band and the red band. Okay, that's our combination. So initially we subtracted, and then we divide that subtraction with the addition of the infrared, near infrared, and the red bands. Okay, so that's how you calculate the NDBI, and then we simply present the NDBI. We create the map, we create the layer of the NDBI using our visualization parameters that we just created. Okay, and this is what the NDBI values or NDBI maps looks like. Okay, let me just unhide or unselect those ones. Remember, there is 5, 7, 8, and 9. Remember, we said that it's a little bit difficult to interpret it or to visually detect any changes simply because the NDBI numbers are so small, and and the fact that we're so far out, we're so it's such a big specific area. So that's really what, and then we said we can zoom in and we can use our inspector and all these sort of things. Then we can obviously create histograms, or we can add a histogram um, for our NDBIs. In this case, I've just generated 2 histograms. I've generated the histogram for the LandSat 5 NDVIs and for the LandSat 9 NDVIs. Okay, and the reason for that is there's no overlap between the LandSat 5 period and the LandSat 9 period. So they're very distinctive periods, which allows us to visualize or to explore differences in NDVI for the specific locations. First, before I get there, I create some options for my histograms, in that I want a title, this font size, and I'm labeling the axis. Okay, so again, this is the name of this particular histogram parameters, where I'm including it as this. This is up to you. It's up to you, your discretion, to decide what name you want to assign to this visualization parameter or this histogram parameter. The title that I'm giving is LandSat 5 NDVI. The font size in all cases is 10. Then I'm labeling the x-axis or horizontal axis as NDVI and my vertical or y-axis as count. Again, this is totally up to you, these parameters. It's up to your discretion to decide how you want to use it. And I said I've also created a variable for my NDVI LandSat 9. Okay, so the only difference is LandSat 5 is in the name. And then I'm actually creating my histograms using the standard script that we also used in the um, nighttime lights video tutorials. Exactly the same, where we give our histogram a name, we refer to our image that we want to present in our histogram, which is the NDVI LandSat 5, which is this one here that we are displaying. My region of interest, my scale, and my um, um, size of each bin. Now remember, this is a value from -1 to 1, so the bin sizes will be fairly small. You can even go to 0.1 if you want to. And then I'm going to include my options, my parameters, my histogram parameters, which is this. Remember, I called that options NDVI 5. So I am going to include my options NDVI. Okay, so that will include those parameters within the histogram. And then I'm going to print the histogram, meaning it's going to show up in my console. It's going to display in my console. And I do exactly the same for my LandSat 9 NDVI, where I've also exactly the same, call the image for my region of interest 502. I then include the parameters that we've just created there, the title, etc. And then I'm going to print it. And voila, I click run. Remember to save, always save, run and save, run and save. And there is my 2 histograms. You can see there's the name that I've given them. There's the y-axis name and the horizontal or x-axis name, and they are in size 10 or font size 10. As we remember, there's a font size 10. You can play around with these numbers. You can even change the colors of the actual bars. That's up to you. Okay, if we compare the two, remember, you can clearly see from LandSat 5, the early periods to the current period, there's been a marked change in the NDI values um, for all the individual locations within my region of interest, in that the values that has a 0 NDVI or close to a 0 NDVI has marked decrease, and the values that have positive NDVIs have marked increase. You can see there 99,076. You can see the values closer to 0.5 and above has increased. So if you just look at these two histograms, the general conclusion would be that there's been a marked improvement in the NDBI values in general for the whole region of interest. Yes, there may be some areas where the NDBI actually decreased, and I think we showed it in the previous video tutorial, but in general, there's much more higher NDBI locations currently than what they used to be previously. Now, it can be because of better rainfall, can be because of change in agriculture, and there could be a number of reasons for that. Anyway, so that's a nice way of presenting the NDBI in terms of the statistics thereof and in terms of visually presenting the NDBI. Now, that's just one particular index that we can create. The next index that we're going to create is what we call the Normalized Difference Buit-up Index. Now, as I said, where the NDBI gives us an indication of the state of vegetation or vegetation cover, the Normalized Difference Business Built Index, sorry, not business built, the Normalized Difference Built Index emphasizes manufactured built-up areas. It's a ratio based to mitigate the effects of terrain illumination differences as well as atmospheric effects. In a nutshell, it's an index that tried to present built-up areas or areas where there's been some disturbance in terms of its natural state. Okay, and that's what the NDBI it's tried to highlight urban features in your region of interest. Okay, so how do we calculate that specific image? Let's just open it up so it's not that blurry. So that's our same methodology where we subtract two bands and we divide that subtraction with the addition of the same two bands. So in this case, we use band 5 and 4. Okay, now what is band 5 and 4? Let's go to our LandSat 5 landing page. Band 5 is the short infrared, okay, surface reflectance, short infrared 1, and band 4 is near infrared. Okay, that's for LandSat 5. So it is the short infrared 1 subtracted by the near infrared, okay, short infrared, short wave infrared, that's correct word. The title, short wave infrared minus the infrared, subtract those two ones and then divide by the short wave infrared plus the infrared. Okay, short wave plus near infrared. Okay, so that is the calculation of the NDBI. Okay, and we do that for LandSat 7, same bands, but remember then for LandSat 8 and 9 the bands changes. In the LandSat 8 it is 6 and 5. Let's confirm. 6 is shortwave infrared and 5 is near infrared. Okay, so we generate the NDBI for LandSat 5, 7, 8 and 9 based on the shortwave infrared and the near infrared. The shortwave infrared and the near infrared. Okay, we do those calculations. Now we've calculated the NDBI. Remember, the NDBI also will have a value between -1 and 1. Okay, and there's our visualization parameters for the NDBI, which is between -1 and 1. And there is our color palette or color scheme for our NDBI. Okay, so we're going to add each of these NDBIs to our layers, and we're going to create, include or present it based on our visualization parameters, and we're going to give it, sorry, not that one, there we go, there's the NDBI, and we're going to give it a name. Okay, so let's then see how the NDBI looks like. Let's unselect the NDBI, and there's my NDBI presentations. So let's quickly go out of that. There's the NDBI LandSat 5. And again, my color palette. I've used this color scheme from white to dark red. Okay, so that is from -1 to +1. I import it and I simply just, you see, there's the codes that I've used. You can either just copy and paste the codes from this window, or you can simply import it, copy and paste it from there into your script. There's our script. You can see if I go to the dark red, it is #CO. You can see it's #CO054D. It's exactly the same. Okay. Makes sense. Okay. Same problem as previously, that if we go from the NDBI LandSat 5, we go to 7, you can see it's very, very difficult to visually interpret any changes. So it's very, very difficult. Just for intersect, let's just compare the NDBI and the LandSat and the NDVI. You can see there, they are almost mirror differences. If I compare the two, one another. Nonetheless, let's try to zoom in and see if we can. Let's go to our trusted area where we have uh, the town itself and some um, mines and railways and Air Force Base and agricultural areas and coastal areas. Let's see what that images, NDBI images, looks like. Okay, so just while I'm there, let's go. I haven't yet created a histogram for that, but to do that, you simply just copy and paste it from the NDVI ones, and you just change it to. So while we're waiting there, let's, for example, do one. So remember, we're going to first look at the parameters. Let's take that one. Okay, so we're going to create both of them. And we're basically just going to copy this code and to where we've got our NDBI. So let's just paste it in there. So I'm going to change it to NDBI. So this will be NDBI. Same with this NDBI. So then nothing changes there. We keep everything the same. This is NDBI. So we just got change all the references to NDVI to NDBI. So this will be NDBI, NDB. We'll run it now to see that it works. NDBI. Let's make. We just need to ND. We just need to cross-reference to make sure that all these changes are done. ND. We'll run it now to see that. NDBI, NDBI. Let's just quickly make sure. NDBI, 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 NDBI. There we go. There, we've missed that one. NDBI, NDBI, histogram, NDBI, LandSat, NDBI. Okay, look, all correct. But while we're waiting, before we run that, you can see the presentation of, let's quickly just have a look at the NDVI value. It's going to take a bit of time now. Yeah, it's going to take a bit of time now to load, but let's just make sure that, again, while we're waiting, that our NDVIs are all correctly presented. And then we're going to run it. Okay, it all looks pretty much on track. So let's give it a couple of seconds while we're waiting. I will be back soon. Okay, now that it has loaded all the images, let's compare them. So there's my, remember, there's the NDVI image, and there's the NDBI image. And you can see the stark difference in the NDBI is clearly highlighting these man-made areas. You can see there's the mine, there is the town, there is another mine, There is the Air Force Base, there's the harbor, etc. So that you can see, let's quickly just go, you can see the difference between the NDBI and the NDVI. Okay, so let's look at Landsat 7. You can see definitely some differences here in areas where the NDBI has number have increased and versus decreased. You can clearly see that. Look at the NDBI Landsat 8 and the NDBI Landsat 9. Okay, and we can do the same with the inspector. Let's select an area. Let's use, okay, let's try to use this. Okay, so let's try, okay, so let's try this area here. Let's just, eeny, meeny, miny, mo. What shall we do? Okay, that area there. Okay, so let's highlight that specific area just to get an understanding of its NDVI. Let's have a look and see. There is the NDBI for Landsat 5 minus 1, minus 0.1, minus 0.13, and 0.19. So its um, values moved closer to the minus side. Um, so let's look at this particular area, which we know. Um, let's have a decrease that. Let's have a look at an area where we know is high in DVI. Okay, so let's quickly go there. This is a high in DVI area. So let's click at that just to confirm that the NDVI for that specific area is increasing. Let's just quickly go there. So there's the NDVI. You can see the NDVI is decreasing and quite high. Let's look at the NDVI. The NDVI is small and decreasing. So from this, you can see there's some sort of inverse relationship between the NDVI values and the NDVI values for a particular location, which makes sense since um, high vegetation cannot happen where there's urban structures or buildings. Where there's a building, there can't be vegetation and vice versa. Okay, so it makes sense that the NDVI and the NDVI value will actually be inverse correlated, which clearly this say. In general, what we should actually have done with our NDVI is actually put it in reverse, where the white is areas where there is, or green for the areas where there's little buildings, and red where it is buildings. So in fact, we should actually do the reverse here. Remember, I spoke about the reverse. Uh, let's quickly run it and see. I doubt it will load in time. But anyway, we will obviously now also generate the histograms for the NDBI. Let me just untick the LandSat and all these things. Hopefully it will, let's just do the NDBI 5 and see what that, hopefully this will improve the speed. Okay, so let's wait. There's the NDBI values or histograms, and now it will generate the NDBI values as per our specific code. Okay, let's zoom in to our trusted area and see we can get. Okay, so there's the NDBI values for Landsat 9. We're just waiting for the NDBI values for our Landsat 5 to display. You can see there's um, uh, quite a bit of values to the lower level of the NDBI range than the higher level. Okay, so let's wait and see what the histogram for Landsat 5 informs us. I'll be back. Okay, and here we have it. Remember, we have reversed the color scheme for the NDBI by using the reverse. If we go there, where is it now? Using the reverse code. So let me just, where is it now? Um, There we go. So we reversed it by using this code. So it's not, so the dark reds will be where there is high um, urban structures and urban settlements, or let's put it low NDBI, low vegetation. So we reversed it, we've created it, and we've created, remember, we've created the histograms, and there's our two histograms. So there's the LandSat 5 histogram, and you can see there, again, a lot of values around the zero, some values on the positive side, a couple of values in negative, but you can see that it just reversed to 2009, where we have more values on the negative side then we have values on the positive side, majority still. And here is the visualization of it, and you can clearly see, and you can see that it does highlight areas of urban structures. This is a river, remember, we have to be very careful about sand and urban structures in that its spectral reflectance are very, very similar. So first thought, if you will say this is, representing urban structures, but no, this is a river, this is sand. So yeah, but you can see it's trying to highlight the urban structures to a large degree. You can see all these little places here. Now again, with color schemes, you should that should improve. Okay, so the visualization with all will be in the visualization parameters. Okay, so we've now created the NDBI. We've reverse colored its visualization parameters, and we've created a histogram for it, and we've now presented it, and we can compare it with the NDBI. And in general, there is this inverse relationship between the NDBI and the NDBI. Okay, I hope and trust you enjoyed this tutorial video. Yeah, it's interesting stuff that I think that we're working with. We're still working with the daytime imagery as derived from the Landsat series. There's still lots to do. We'll get cracking on those video tutorials very, very soon. And stay tuned. I'll see you on the other side.